Students, this is Sivakumar, 11th Standard Mathematics, Chapter number 1, continuation of exercise 1.4. Now problem number 5. From the graph y that is equal to sin x, graph the functions y that is equal to sin of minus x, y that is equal to minus sin of minus x, and y that is equal to sin of 90 plus x, which is cos x, y that is equal to sin of 90 minus x, which is also cos x. Okay. First, I am going to construct a graph y that is equal to sin x. For that, I am considering the angles minus 360 to plus 360. Pi refers 180 degree, 2 into pi, that is 2 into 180, that is equal to 360. Here 360, here minus 360. Since pi that is equal to 180, 180 by 2 that is equal to 90, 90 into 3 that is equal to 270. This is 270, here minus 270. Here 180, here minus 180, here 90, here minus 90 and 0. So, I have taken from minus 360 to plus 360. You know that sin 0 value is 0, sin 90 value is 1, sin 180 value is 0. Remember, sin 180 that is equal to 0, sin 270 that is equal to minus 1. And sin 360 that is equal to 0, like that. You must be knowing this property, sin of minus theta that is equal to minus sin theta. So, sin of minus 90 that is equal to sin of minus 90 equal to minus sin 90 according to this property, minus sin 90. You know the value of sin 90, that is 1. So, minus 1, here it is. Like that, sin of minus pi that is equal to minus sin pi. Sin pi value is 0, so write 0 as it is. Next, minus 3 pi by 2, sin of minus 3 pi by 2 equals minus sin 3 pi by 2. Sin 3 pi by 2 value is minus 1, here minus into minus 1 is plus 1. Then sin of minus 360, sin of minus 2 pi that is equal to minus sin 2 pi. Sin 2 pi value is 0, so here minus 0, you put 0 only. So, I am going to plot all the points, right? Minus 2 pi by comma 0. Here I have taken minus 2 pi to plus 2 pi. This is minus 2 pi. Here 0, 90, keep on adding 90, 90 plus 90, 180, 180 plus 90, 370, sorry, 270, 270 plus 90 is 360, like that. 0, minus 90, minus 180, minus 270 and minus 360. All the points to be plotted 0, 0, pi by 2, 1, I have taken here 1. So, pi by 2, 1, you know how to plot the points in a graph. Pi by 2, 1, pi, 0 lies on which axis? X-axis. 3 pi by 2, minus 1. Here it is. 3 pi by 2, minus 1. This is the point 3 pi by 2, minus 1. And that next one is 2 pi, 0 lies on which axis? X-axis. Like that. Minus pi by 2, minus 1. Here it is. Minus pi by 2, minus 1. And minus pi, 0. Minus pi, 0. And the next one is minus 3 pi by 2, plus 1. Here it is. And the last one is minus 2 pi, 0 lies on which axis? X-axis. Join all the points, you will be getting a curve. You are not supposed to use a scale for joining that points. Just freehand only. Have to join everything, you will be getting a curve. This is sin x curve, y that is equal to sin x curve. Okay. Now, subdivision number 2, y that is equal to sin of minus x. From this graph, you have to draw this graph. Y that is equal to sin of minus x that is equal to minus sin x. According to this property, sin of minus theta equal to minus sin theta. So, sin of minus x equal to minus sin x. Here y that is equal to plus sin x, here y that is equal to minus sin x, very simple. We are going to take the angles minus 360 to plus 360, no change at all. Even here we have taken minus 360 to plus 360. Look at the y values 0, 1, 0, minus 1, 0, 1, 0, minus 1, 0. Here y that is equal to minus sin x. So, we have to multiply each and every one by minus, because this is plus sin x, here minus sin x. 0 becomes 0 only, plus 1 becomes minus 1 if you multiply by minus, 0, 0 only, minus 1 if you multiply by minus will be getting plus 1, 0, 0 only, 1 if you multiply by minus will be getting minus 1, 0, 0 only. Minus 1, if you multiply it by minus, you will be getting plus 1, then 0, 0 only. Now you can plot all the points minus 2 pi comma 0, minus 3 pi by 2 minus 1, etc. up to 2 pi comma 0. Here it is. Have plotted all the points 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is a curve y that is equal to sine of minus x. Sine of minus x that is equal to minus sine x. This is y equal to sine x. This is y that is equal to minus sine x. Already I have told about that concept of reflection. The graph y that is equal to minus f of x is the reflection of the graph of y about x-axis. Minus f of x is the reflection of the graph f about the x-axis. Okay. This one already have discussed. This is y equal to sine x. I considered sine x as f of x. Y that is equal to f of x. This one is y that is equal to minus f of x. So this graph is the reflection of the graph y that is equal to sine x about the x-axis. Correct? Look at that graph. I'm comparing these two graphs. This part of the graph is symmetrical about x-axis, a reflection on x-axis. The entire graph is reflection about the x-axis. Correct? Now, subdivision number 2. Subdivision number 2, y that is equal to minus sine of minus x. Minus sine of minus x that is equal to minus, write as it is. Sine of minus x, you can apply this property. Sine of minus theta that is equal to minus sine theta. So, sine of minus x equal to minus sine x. Minus into minus plus sine x. You will be getting the same graph. Here y that is equal to sine x. Here also y that is equal to sine x. So, write all the y values without changing. 0 to 0. Here. No change at all. So, you will be getting the same curve y that is equal to sine x. These two are same only. Look at that. These two are same. This is a given graph y that is equal to sine x. This is subdivision number 2. Particularly this graph is the reflection of this graph about x-axis. I have mentioned here. Reflection, correct? The entire red color is a reflection. The entire red color is the reflection of this graph. So I have mentioned here, this graph is a reflection of the graph sine of minus x. About what axis? X-axis. So again I tell you, this subdivision number 1 is a reflection of this graph. Subdivision number 2 is a reflection of this graph about x-axis. Both about x-axis only. So it is nothing but y that is equal to sine x. Look at that. These two are same only. No change at all. The given graph and subdivision 2 are same. So that I have mentioned, it is nothing but y that is equal to sine x curve. So 2 subdivisions are all over. Now we can go for the third subdivision. Now subdivision number 3, y that is equal to sine of 90 plus x is given. 90 plus x and x plus 90 are same only. What form it is? Y that is equal to f of x plus c. Because y that is equal to sine x is given. Y that is equal to sine x is given. That 90 has been added with x only, not with the sine x. Remember, 90 that is added with x only. So you can write y that is equal to f of x plus c. Right? It causes the shift of the graph y that is equal to sine x, y that is equal to sine x to the leftward by 90. C values 90, leftward by 90 units. It is nothing but y that is equal to cos x curve. Particularly this concept already discussed. Look at that. When I explained about the concept of translation, if y that is equal to f of x plus c, if c is positive, causes the shift to the left. C is added with x. Here C is subtracted with x, causes the shift to the right. and d is added with the given function, d is also a constant is added with the given function, causes the shift to the upward. If d is subtracted with the given function, causes the shift to the downward, remember. Okay. So since it is of the form y that is equal to f of x plus c, again I tell you, it causes the shift of the graph y that is equal to sin x, this is a given graph, to the leftward by pi by 2, because c value is pi by 2 units. Okay, we can see, look at the graph. This is a given graph y that is equal to sin x. This graph to be shifted towards left hand side by pi by 2 units. It is passing through 0. It should be shifted to the left hand side by pi by 2 units, means it should be passing through minus 90. Look at that, minus 90. Minus pi shifted to the left hand side by minus 3 pi by 2. Okay, like that. Pi should be shifted to the right hand side by, left hand side by pi by 2 units, mean here it is passing through pi, it is passing through pi by 2. The entire graph should be shifted towards the left hand side by pi by 2 units. Again I tell you, each and every point to be shifted towards the left hand side by pi by 2. Look at that, 2 pi is shifted to 3 pi by 2, here it is. This point is shifted to here by pi by 2 units, here it is. And pi is shifted, the next point pi is shifted to this point, pi by 2, it is passing 3 pi by 2. The next point, here it is, this point is shifted towards left hand side by pi by 2 units, here, look at that, the curve is passing through here. Next, this point is moving towards the left hand side by pi by 2, the curve passing through here. Next point, here it is, then this point is moving towards the left hand side by pi by 2, here it is passing through. Next point, here it is, this point is moving towards the left hand side by pi by 2, here, look at that, passing through minus 3 pi by 2. And the last one, this point is moving towards the left hand side by pi by 2, here, look at that point, here it is, curve passing through this point. This red color graph is nothing but cos x. This is a cos x curve, because cos 0 value is 1, 0, 1. Cos 90 value 0, pi by 2, 0. Then cos 180 value is minus 1. Here I have to mention 1, minus 1. Here also I have to mention 1, minus 1. Okay. Then cos 270 value 0, cos 360 value that is equal to 1, cos minus 90 value 0, cos minus 90 value that is equal to minus 1, cos of minus 270 value 0, cos of minus 360 value is 1. We will be studying elaborately in the chapter trigonometry. Now subdivision number 4, last subdivision. Listen, y that is equal to sine of 90 minus x. Sine of 90 minus x can be written as sine of minus of x minus pi by 2. Minus into x minus x, minus of minus pi by 2, that is equal to plus pi by 2. Now I am considering x minus pi by 2 as theta. So what form it is? Sine of minus theta. You know that sine of minus theta that is equal to minus sine theta. Minus sine theta. Which one is theta? X minus pi by 2. Okay. First we can construct sine of x minus pi by 2. This is of the form, particularly this portion, sine of x minus pi by 2. Here it is. Causes the shift of the graph y that is equal to sine x to the rightward by pi by 2 units. Because what form it is? Y that is equal to f of x minus c. constant is subtracted with x. If it is of the form x minus c, you know that it causes the shift of the graph, the given graph y that is equal to sin x to the rightward by pi by 2 units. Here, for this portion, already we have discussed, we have shifted to the leftward by pi by 2 units. Now this graph should be shifted to the right hand side by pi by 2 units. Right hand side. Passing through 0, it should be passing through pi by 2. Look at that. Pi by 2. Now this point comes to this place. Right hand side. Look at that. Red color. Complete red color graph. Next, this point shifted towards the right hand side by pi by 2. It should be passing through 3 pi by 2. Yes, it is passing through 3 pi by 2. Like that, the entire graph, this green color graph, this is y that is equal to sin x, shifted towards the right hand side by pi by 2. This is the red color one, that is sin of x minus pi by 2. Sin of x minus pi by 2. Okay. Now, this part is over. Now we need minus sin of x minus pi by 2, that is sin of pi by 2. These two are same only. Sin of x minus pi by 2, this is minus sin of x minus pi by 2. Already we have discussed in the concept of reflection. If it is f of x, this is minus f of x. Minus f of x is the reflection of the graph f of x. I consider this is f of x. About what axis? X axis. So it is nothing but y that is equal to cos x curve. Okay. So once again, minus sin x minus pi by 2 is the reflection of the graph sin of x minus pi by 2. So now we can construct the graph. This is the fourth subdivision graph. Green color one is the required graph. This is the reflection of the red color one. So which one is the resultant one? Green color is the resultant one. Y that is equal to sin of pi by 2 minus x. This is the fourth subdivision. This green color graph is the reflection of the red color graph. About what axis? X axis. Look at that. This area is reflected along the x axis. Here it is. These two are reflected, these two are reflected, these two are reflected, reflected, these two are reflected. Okay. So all the four subdivisions and all over. So it is also nothing but y that is equal to cos x curve. Particularly subdivision 3 and subdivision 4 both are cos x curve only. See, subdivision 3, here it is red color. Subdivision 4, the resultant graph is green color. Same shape it is. Look at that. Same. Okay. So both cos curve only. So question number 5 is completed. I'll be teaching that problem number 6 in the next video. Thank you, children.